Good evening, Professor. This is Sarvesh from Group 2. Right now, I'm gonna cover the objectives and methodology as well as the benefits to society of paper-based electrical circuits. It the paper-based electric circuit offers far flexibility than an actual electrical circuit, so that we cut and shape it with respect to our needs. One of the main objectives is that it can be easily accessed since it is made of paper. Also, its budget is way lower than an actual circuit. The components that are used here are the copper tape, LEDs, coin cell battery, and the paper material. The paper material should be made of PEDOT and PSS. We are looking at the basic structure of the paper-based electrical circuit. Right now, I'm gonna cover the methodology. The basic components like LED, coin cell battery, and copper tape must be present. Necessary supplies and conductive links must be present. For circuit design, we can plan the layout as per the need. We must attach the components at their designated positions on the paper. We also must integrate the power source. Also ensure the polarity should be correct. Finally, check whether it functions properly or not by testing and troubleshooting, and then make a document in it. Right now, we are looking at how the paper-based electric circuit are taken through the art, and we are looking at the printed circuit board (PCB) and how it process and also the non-printed integrated circuit textile (NIT) processes. Now we're gonna discuss the benefits of paper-based experiment to the society. The paper-based electrical circuit is easy to access and provides a low-cost alternative solution to the traditional circuit boards. The materials that used to build PBC are either biodegradable or usable, which makes it eco-friendly. The PBC merges technology with art and gives opportunity to unique and creative thoughts. Also, the PBC, like the paper-based electric circuit, are greatly used to help out the local issues, and it is a great way for gaining economic growth and social development. So even we can use it in for community engagement. In summary, a paper-based electric circuit bring numerous benefits to society, including accessibility, education, sustainability, innovation, artistic expression, and so on. It can be also used for students' first hand-on experience for of students of all age are included. So we are looking at proper function of paper-based electric circuit since like it is used for underwater experiments. We are looking at the image of that. Thank you for giving me an excellent opportunity.
Hi, this is Madesh. Now I'm going to explain about logics for designing paper-based circuits. Paper-based electronics are designed with three principles in mind: affordability, flexibility, and sustainability. Firstly, the paper-based circuit is cost-effective. We use inexpensive material like paper, making it accessible for anyone to experiment and innovate without a hefty price tag. Secondly, flexibility is a core design feature. Paper circuits can bend and adapt, allowing for the creation of wearable electronics and unique shape that traditional circuits can achieve. Lastly, there's a strong emphasis on sustainability. The material used are often biodegradable or recyclable, reducing the environmental impact compared to the traditional electronics. Now we'll see about deep understanding on the experiment. Deep understanding in paper-based electronics is like journey that combines theory and hands-on experience. Imagine crafting paper circuits where you learn to design, cut and troubleshoot. This practical knowledge complements the theory and gives you a full picture of paper-based electronics. Now picture adding sensors like touch or light sensor to your paper project. This is a key part of deep understanding, making your creation responsive and interactive. It's like giving your paper crafts a smart and interactive touch. But there's more. Learning to program microcontrollers is like giving your paper circuits a brain. It lets you control over complex action, making your project more dynamic. And don't forget to troubleshoot. So deep understanding in paper-based electronics involves hands-on skill. It's not about knowing the theory, it's about unlocking the full potential of paper-based electronics in practical and creative way.
Hey guys,
Thank
this
you.
is Abhishek Einstein, and today I'm going to talk about the confidence on fabrication and self demonstration. The pros of custom PCB are their space saving and condensed circuitry, and the automated production reduces labor costs and increases repeatability and quality. And the integrated LED lights also provide at-a-glance verification that the PCB is functioning. And some of the cons are that the initial design time and tooling required can be quite taxing, and they're difficult to revise multiple times, and they're quite fragile, and high amperage can ruin the PCB. By making the switch to the custom PCB, the redesigned component is less cluttered. Based on the pros and cons of custom PCB, we can derive that custom PCBs are well suited for high volume applications that don't change often. Once the initial design and tooling are finished, the production can be very inexpensive, and you can be confident that each PCB will be identical. If the electrical design will be revised frequently, or your volumes won't realize a return on design and tooling costs, a custom PCB may not be the appropriate solution. And fewer wires in a particular assembly may also mean that less labor and also reduce risk of error, both of which can also contribute to the lower manufacturing cost and higher quantity. The compactness of custom PCBs allows electric components to be packed tightly together, making the final product smaller and more compact. This is especially important for portable devices where space is at a premium. Reliability of a custom PCB is also very helpful, as a well-designed PCB is essential for long-term functioning, and electric performance of PCB design can have a significant impact on the electric performance of a certain device. By making a switch to the custom PCB, the manufacturing efficiency can also improve, as the manufacturing process is improved upon, and properly designed PCBs can help reduce assembly errors and improve the overall production yield as well. Now let's talk about a few principles for improving the confidence in our design. First, we need to look at the design for manufacturing, because if the board cannot be properly manufactured and assembled, it is essentially useless. The design for manufacturing means your circuit board is designed in such a way that it becomes feasible to build by a PCB manufacturer. The truth is, DFM should be considered and followed during the design and not afterwards. Not paying attention to it will lead to board respins, which is essentially the fact that we have to do it again right from the beginning, and also less reliable boards. So we need to understand the principles and be confident in our design. Next, we will talk about power integrity. The idea of power integrity at its core is maintaining proper levels of voltage and the current at all parts on the PCB. But there are more factors that have power integrity, such as voltage, ripple, and signal switching noise output. The electromagnetic interference and managing the power distribution network is also important. Poor power integrity can cause the devices to not operate properly or at all. However, if the power distribution network provides the right amount of power, then the output voltage from the PDN is still too large. You may have devices on a PDN switching signals and sending the wrong data due to involuntary switching caused by that PDN ripple because of the ground bounce. Next, we will look at signal integrity. So you have a design that can be easily manufactured and put in time to ensure that the circuit devices have clean power. It should be fine, right? Not necessarily. If you want to do a high-speed circuit design like DDR memory, wireless, and RF designs, you absolutely need to understand signal integrity. The integrity of a signal is paramount to ensure your high-speed or Internet of Things PCB works properly. Otherwise, you can have the same respin issues, or poor power delivery network can also cause. While the following list is non-exhaustive, here are some factors you need to design for when managing signal integrity on your PCB. Clock distribution, signal paths, stubs, noise margin, transmission lines, and resistive termination. The list can go on and on. Unfortunately, if you want to make a reliable high-frequency printed circuit boards in the hundreds of thousands or even megahertz range, then you need to be good at signal integrity. Typically, if the transition times are small compared to the trace length, half of the total time the signal takes to travel around the trace, then you need to consider your PCB as a high-speed circuit. This blog post provides more information on how to identify if the design is high-speed. So now we have reached a conclusion of this topic. So, having a thorough understanding of the design for manufacturing, power integrity, and signal integrity is essential to be confident while designing the PCBs. Once you master these three skills, the sky is the limit. You will start looking at every PCB differently and will be able to redesign and improve them at will. And also charge a lot of money for it if you want to. So the information we gained from this project for future development is that we could determine how uh, each circuit could be used for different tasks and how the task could be achieved. So we could draw schematics according to our knowledge, data sheet requirements, or other simulations. These are mostly parallel process which happen at the same time. You can also review the final schematic according to a predefined checklist. Either look for one online or you could put together one on one and draw the layout and look up every component's footprint and dimensions and check for the compatibility with different portions of our design and review the layout with the checklist like the schematic. The first we need to order the first PCB and populate the first part and start debugging and repeat for all functional blocks until the board is fully populated. We need to then try to fix mistakes by changing component values and scratching and reconnecting traces with magnet wire or redesigning entire parts of the circuit. Then the process starts again, although a lot more simplified because the hard work is already done. It might take a couple of tries to get it right, but even for hobbyists, this isn't a big deal as basic PCBs aren't that expensive. Keep an eye on the components cost though. Look online for schematic or design rules, checklists, debugging guides, and hardware boards techniques. Example, the footprint you do is too small for the actual component. Anyway, thank you for looking at this topic with me today.
Okay, good afternoon, everyone. I am Lingeshwar, register number 23BEC1182. I am going to give you a brief presentation on theoretical understanding of paper-based electronic circuits. What are paper-based electronic circuits? Paper-based electronic circuits refer to electronic circuits that are printed on paper, directly on paper. Here, paper is used as a substrate in place of circuit boards used in ordinary electronic circuits. Instead of wires, we are using ink with conductive properties, which is printed directly on the paper by using technologies such as inkjet printing. In the same way, we can print resistors, capacitors, and transistors to make up an electronic circuit. Now, why do we use paper as a substrate? There are many advantages of using paper as a substrate. For example, paper is flexible, lightweight, low cost. It is very easily printable using inkjet printing, and it is also biodegradable and disposable. Okay, how do we use ink as foil? We are able to formulate special inks which are which have conductive properties by adding silver nanoparticles or silver flakes or copper nanoparticles or copper flakes. The ink is then supplied to an inkjet printer which prints the ink on the paper basis substrate. Now, how are electronic components printed on the circuit? Printed on the paper basis substrate. Resistors are printed using ink formulated with resistive properties. Again, jet printing is used here. To print capacitors, ink formulated with dielectric properties is used, and conductive ink is also used alongside. The dielectric layer of the capacitor is printed with dielectric ink, and the capacitor plates are printed using conductive ink. Similarly, for inductors, we use magnetic ink and conductive ink to outline the inductor. Now coming to transistors, we use the ink with semiconductive properties to print out the PNP junction to the transistor. Transistors so printed are very thin, and they called thin film transistors. And this process can again be done using inkjet printing, which is normally used in our project. Thank you.
As we ventured into the design and execution of our flexible paper-based electronic circuit, we didn't just explore the technical intricacies, we also discovered an unexpected treasure in entrepreneurial skills that have been incubated and nurtured throughout this journey. This project, more than a technical pursuit, it became a training ground for essential entrepreneurial skills from solving unexpected challenges to strategically planning each phase. Our journey has been a masterclass in adaptability, communication, and critical thinking. Our entrepreneurial mindset wasn't confined to the theoretical aspects, it played a starring role in the practical execution of our project. It helped us navigate uncertainties, make informed decisions, and manage the project effectively. These entrepreneurial skills aren't just confined to the realm of the project, they have real world relevance, providing us with tools to tackle not only technical challenges but also navigate the ever challenging landscape of innovation and technology. As we look ahead, these skills aren't just skills, they are assets. They are the foundation upon which we will build our future endeavors, whether it's pursuing advanced studies or venturing into the professional world. We are equipped with the mindset and skills needed for success. As we conclude our presentation, we collectively express our gratitude for your attention. Each member of our team has played a crucial role in this collaborative project. We are proud to share our work with you and we appreciate your time.